We want to determine the general solution of this differential equation. First, let's write it in standard form. So we would have dp dt plus 2t p minus p equals 4t minus 2. In fact, this is 2t minus 1 times p. So let's write that way. dp dt plus 2t minus 1 times p equals 4t minus 2. Okay, so this is a linear differential equation, and so we're going to go ahead and find the integrating factor. It's first order and linear. So the integrating factor, we'll do that here on the side, is e to the integral of 2t minus 1 dt in this case. And so that is going to be e to the t squared minus t. The next step is we multiply this equation times the integrating factor to obtain e to the t squared minus t times dp dt plus 2t minus 1 e to the t squared minus t times p is equal to 4t minus 2 times e to the t squared minus t. And we quickly see that on the left-hand side we have p e to the t squared minus t prime. If you take this term here and you find the derivative, you will see that it's exactly the same as this two terms up there. And so then that's equal to, and I'm going to pull out a 2 out of this term, a 2 times 2t minus 1 e to the t squared minus t. The reason I do that is because I'm foreseeing that when I integrate, I'm going to need it. I like to see it that way. So then we're going to integrate both sides. Here we're integrating dt and dt. So on this side, we just get p e to the t squared minus t. On the right-hand side, if we use substitution and u is t squared minus t, then du is 2t minus 1, and that's where this 2t minus 1 comes from. And so if I use this u substitution in there, I'm going to get 2 e to the t squared minus t. Plus c. Finally, we're going to go ahead and solve for p, and for that we'll multiply times e to the minus t squared minus t, the whole thing, and we get p is equal to 2 plus c e to the, let's see, t minus t squared if I add this term here, but I just go ahead and distribute the minus sign. The solution is defined in all the real numbers because everything has been continuous from the beginning, all our functions. If we look here, this function is continuous for all t, and this function, I should say, this function is continuous for all t, and so is this function. And transient terms, well, it would be only if t minus t squared was less than 0. And whatever values give us that would make this to be a transient term. But this is our explicit solution right there.